Hi, I'm Gonzalo Maldonado. I'm a tech lead at Nextdoor, and this is my talk, Beyond Writing from Scratch, using observability to modernize systems lacking tests. Another title for this talk would be How to Fix an Old System Quickly. This story is based on actual events, some incidents having changed for dramatic purposes. So there's this idea called Gordian knots, and they come from from history. Alexander the Great once was faced with this really difficult challenge, which was unraveling the Gordian knot. It was a knot that was really knotted, it was really messy, and no one knew how to undo it. No one knew how to go and fix this mess. And what he did is he just split it right by the middle. He just cut it right through the middle, and it worked. Like, that was a very blunt but a really valid solution to this problem. On engineering, we're faced with those kind of situations all the time. And one that we use a lot is extracting a microservice out of a monolith. We have a system that we know that we need to unravel, we need to fix, and taking it out, putting it right in the middle, it works great. It's a proven technique that we do over and over again. We did exactly that. We had a monolith that was working okay, but we needed something way better. So we went ahead, we extracted it to a microservice, and at the beginning, we were feeling really confident with it. At the beginning, it was working really well. It was week one of the new service, and we saw that it was twice as fast with half the bugs. And we did a gradual rollout. We didn't start with 100% of the users. We said, like, hey, let's start with 20% and see how things go from there. But then weeks passed, and now we're at week 10. And yes, the system was still great. It was still twice as fast, half the bugs, but it was only available to 20% of the users, and we just wanted to roll out to everyone. And we felt stuck, and it was not very clear for us, like, why are we stuck here? Why are we not making progress? And as you can guess, like, we felt like we were stuck on legacy code. We were stuck on something that we felt like was really impeding our progress. So before going a little further, let's focus on that. Let's focus about what legacy code is anyways, because it's not necessarily just old code that is legacy code. There's this definition by Michael Feathers, who has an excellent book called Working Effectively with Legacy Code. And he uses this definition that's very basic, but it works great. Legacy code is code without tests. And this works well for most situations where you say, like, hey, there are no tests. I just need to add tests. I'm out of legacy code. Problem solved. It's a little superficial. It thinks a little harder than that. I like this definition by Dylan Beatty, that's consultant, that says legacy code is code that is too scary to update and too profitable to delete. This is basically code that it has been around for a bit, or maybe for a while, and you know it works because, again, you're not seeing these issues on production and users are not complaining about it. But it's code that you're scared of changing. And it's code that you feel like, hey, if I tweak something, something will break. And that was our case. We're changing things, and we start saying that things were breaking in ways that were not obvious for us, in spite of having a test suite and everything. And there are many reasons why this happens. And there are many reasons why, in spite of doing your best efforts of doing good test suites and making clean code, this still happens. And the reason why is that Valentino Breitenberg, back in the 80s, when he was doing work on modeling animal behavior, he came up with this law that uphill analysis, downhill invention. And what this means for us is that creating a new system is always easier than understanding an existing one. So whenever you build something new, like, you're discovering things for the first time, you're going and having this productivity because, like, okay, I can go and make new things. And sometimes you don't even stop to think, like, hey, is this something that people will understand? Is this something that will be easy to extend? You're just discovering this yourself, and this is easy, and you're not thinking about all these second nature things. But then the problem comes when you actually need to go back and revisit that system. Like, the assumptions that you had that were very clear in your head might not have been completely captured on your test suite and your documentation. And unfortunately, it's really hard to change a system that you don't understand. If you don't understand all the moving pieces and the assumptions that are made underneath for it, it will be really hard for you to be productive with this code. which brings to this next chapter. We all have deadlines in some shape or form. We always have to go and make sure that you're shipping. And this can be a little strange when you're like faced on having this requirement, like, hey, I need to refactor this code, I need to change it to understand that. But it can take a while just doing that process. And in the meantime, like sometimes you feel like you're blocking the release of the software because of this. So at this point, we're spending a couple of weeks refactoring the code, cleaning it up, making sure that we can get it out. And that's when our product manager was like, hey, enough, we need to ship. Can you go to 100% next week? And of course, we're like, can we? And at the beginning, we're feeling somewhat confident. But then weeks pass and we're like, okay, we really don't have time to go and rewrite this. We cannot rewrite this from scratch. We still need to refactor, but we need to do it some way that this is faster. And at the beginning, we were feeling quite confident because we had a test pyramid. We basically had 30% test coverage, which again, is not great, but it's not the worst. It's usually enough. And especially it's usually enough because we had a test suite like this one. We had unit tests, we had integration and end-to-end. We felt like, okay, our code is definitely going to be covered well when we are executing this test suite. However, when we were making changes, every time we change something, we start seeing bugs happening on staging. We're seeing things getting all past these 3 layers, and it was not obvious why it was happening. Like we're saying, like, hey, this has the right shape, it looks the right way. Why are we seeing so many bugs happening? In reality, this is how our test suite looked like. There were holes all this 3 layer, and it's always normal to have holes on different layers of your test suite. But the problem is what is called a Swiss cheese model. The issue with having these holes on these layers is there are situations where they just line up perfectly. Where they line up, there's a bug over here, and it's going to go all the way through all the 3 layers and hit staging in our case, or production if you're testing production, which sometimes you do, but usually you try not to. And this is really problematic because that number that we had before, it was not true, that 30%. We never really went back and analyzed this number, but it was probably like 10% because there were so many instances of this happening. And again, there are techniques to make sure that this does not happen. There are techniques like fuzzing and other things that you can do to ensure that these layers are working as correctly. But in our case, we didn't have time to just go and fix this all the way through. We wouldn't have time to do the perfect pyramid. We needed something else. This is normal. This happens a lot. And usually engineers just want to ask for more time. Like, hey, we need more time to refactor. We need more time to fix our tests. So before going into how we made this go faster, we need to step back for a second and just talk about like what is the classic way you address these issues. Talking again about Michael Feather's work, he has this technique that is very powerful called Cartesian Tests. And the idea here is that if you just ask the right questions to your code, if you create the right framework, you can learn a lot about the code without having to actually read it or analyze it line by line. Usually this technique is done in these 3 steps. You go and create a harness, then the testing harness. Then second, you write a test that you will expect to fail. You actually don't want this test to pass. You want to see how many different ways your code can break. And then by learning from those ways it break, you can learn a lot about what's happening underneath the hood. So let's go through an example. Let's assume we have a function like this one, which right in the middle, we have this extremely messy code that we don't want to spend too much time understanding. Like that's, again, not the goal here. The goal is to understand how this globally works and what it's doing. So we're going to just create this very basic test. We're going to say like, hey, function, just give me back your output. I'm going to say that it gets fuller. We expect this to break. This is junk, but we expect to learn about how these things work. And just by doing this, we start learning so much about this function. We quickly start saying like, hey, this looks like URL encoding. This looks like it has this particular time format. It has this, it's come back as a string, and it has this shape and form. we learn so much by doing this silly test. Just by doing this test that we knew would break, we obviously knew beforehand that it wouldn't match foobar, but now we learn how it acts, what it expects, what are the inputs, what are the outputs. And this is really powerful. Like, you can get really far with this. And just like anything in life, there are pros and there are cons. The pros of this is that it can be done gradually. It's very easy to just go piece by piece, and it's also easy to do it in parallel. You can say, hey, half of your team work on this, the other half work on that. That's great. And the other pro that is great is that it unblocks you. Sometimes you can be stuck trying to understand a big piece of code, especially when it's very lengthy function. You can take a lot of time trying to understand what's going on. This technique lets you be unblocked. It simplifies into the things that you should be really worried about. But it's not perfect. The first issue it has is that you need to be very careful of making sure that the way you're testing, the way that is set up on your testing environment is the same way that is on production. So for example, if there's a difference, let's say that on testing you use one kind of database and then production you use a different one, that could be a huge change. That could be changing a lot the behavior of your system. And if you're not aware of that, you'll run into issues where the stats that you just wrote, this assertion that you thought it was real, is not true. And the second problem with this is that you require a different mindset that the one you usually do when you're doing software development. You need more of a quality assurance kind of mindset. So instead of thinking how this piece of code will work, you need to start thinking about how can it break? What are the edge cases? What are all the things that I need to think in order to make sure that I understand the behavior? And this takes time. This is not something that most developers know how to do. QA are great at this because that's what they do most of the time. But engineers, they require a little bit of training in that way. The other technique that is very popular for dealing with legacy code is called tracer bullets. And this is an idea that comes from Dave Thomas' book, The Pragmatic Programmer. And it's really simple. It's simple and pragmatic, of course. And the idea here is that you can learn a lot just by aiming at something and see how far you landed from where you wanted to go. Again, a 3 steps process. You go, you find a target, you go and change something, and then you see how far you missed. So let's go over an example. Again, we have this weird function over here that has a bunch of magic variables, and we don't understand exactly what they're supposed to do. One is literally called magic. So it gets kind of hard to understand like what's going on there. So if we just do one simple change, and this is one of the most trivial changes you can do to your code, we're just going to print the line. We're just going to say like, hey, in this piece of code, when it's running, after it has run, right before returning, let's print the results out. And just by doing this, we learn so much about the behavior, even without having to read the code. We learn that, hey, there are multiple items being sent here. Hey, the tally is changing in this way, and then the magic number is actually not a Boolean, it's actually a number, it's changing in these ways. We're learning so much, and we didn't touch the code at all. We just added a print statement at the end of it. And this is already giving us such a great picture of what's going on underneath the hood. And again, nothing's perfect. There are pros and cons here. The pro is that it really shows you how things should behave. Like, this is especially good when you have no idea what's happening underneath. Like, you just throw that log, that console, the print statement, and you will learn how the code is behaving. It will actually show you how things are happening and not just the assumptions that you had before. And the other pro that this has is that you can be guessing completely widely. You can be going a complete different direction, and you'll still learn something, right? It's really hard with this technique not to learn something about your code. But again, nothing's perfect. The cons are that this is also slow to implement. Just like the previous technique, you need to go function by function and add these statements. And ideally, you need to add them at the right places in order to maximize your learnings. Otherwise, you can end up with too much information and not knowing how to understand it. And the problem with this is that it can be kind of hard to know how far you missed. Sometimes you think you're really close to the target and it turns out you're farther along. It can be hard to know just how much more work when you will get there. This happens a lot with this technique that, are we there yet? Most of the times you won't even know. You just want to make sure that you're within some range. And we'll talk a little bit more about how we fix this problem with new techniques. So these techniques work great. And again, if you have infinite time, you will get there. Like this is, using this metaphor, just trying to light a room with flashlights. Like given enough flashlights and given enough time, of course you can light up any room. But you have to have the resources to do that. And most of the time you don't. You have deadline and you want to make sure that you can get there quickly. So we need a lighthouse. We need something powerful. We need something that will give us quick and right ways of understanding what's happening. We just need to shine a big, powerful light at this. So because one of my coworkers was suggested this idea, saying like, hey, we learned about this tool back in the brown bags, Datadog, it was called, something like that. Can we use this? Can we use this tool to make this process faster? And as you can guess, just within this conference, the answer is yes. So let's look into that. We have this brand new tool, and let's try it with the old tricks that we knew before. Datadog is a great platform. It really encapsulates the three pillars of observability. So there's two things that any good observability platform should have: metrics, tracing, and logging. Logging is the most basic of all of these three. Logging is basically saying like, hey, this event happened at that time. We just have a timestamp of an event that happened. This is great. Then we have metrics. Metrics are like, hey, I'm going to count something. I'm going to say that whenever something happens, I'm just going to keep this number to get an idea of how things are behaving. And let's just call it up and down based on time. And then finally, we have tracing, which is saying like, hey, we have a log. How about we scope that log between like, let's say an HTTP request. I'm just going to add an annotation saying like, for these requests, these logs happened. And if you start mixing these three elements together, you get all this richness on your data. If you mix metrics and tracing, you get request scope metrics saying like, hey, for these requests, this is what's going on. This is how much time is spending on these different logs. If you mix metrics and logging, you can get metrics out of logs. You get a bunch of logs and you can see how often this happens. You have a request scoped events. You can say like, hey, this log happens and they only happen with this particular traces. It doesn't happen on all HTTP requests. It just happens on this subset. And then finally, you can mix everything together and you get request scoped variables events, which is great. Like you can get so much richness just by playing with this different pillars. By working with these different elements, you can get so much data and learn so much about your system. So that's what we did. Our requirement was we need to refactor this, and if we use this observability tool, we can achieve the velocity that we wanted. We can move so much faster by extending our knowledge and our techniques with this. So let's go and revisit the first one. Let's go and revisit Cartesian tests. So as you recall, these are the three steps that we had before. We're going to do some very small tweaks to this. Instead of creating a harness, we're going to create a log. We're going to learn our code run. We don't even need to run it in the context of a test suite. We can actually run it on the staging or production, and we'll learn so much. And then finally, just like before, we'll learn how the code really behaves, especially if we run in production. So we had this function before that had this extremely messy code. We're going to do a very small tweak here. We're just going to log. We're just going to log what the output will be. And this is great. This is a screenshot of one of our dashboards. And as you can see here, we got so much richness. We start seeing like, hey, this is actually how the errors are happening. Here's how the things are actually breaking. Here are the different situations where we're unable to parse it as JSON. Here's all these elements that we were not aware of. We didn't know all of the data that we got from this view, which is great. We were able to start thinking like, hey, how do we get on these situations? How come the code is behaving this way? And then Datadog is very powerful. If you click that blue button, which is, again, this is magic. This is great. This is one of my favorite features here. We get pattern analysis. And with this, we get a great idea of like, hey, here's the different patterns that are happening often in our system. And here's how often we have. We actually get a metric out of this. We get a number saying like, hey, 1 out of 10 times you're getting this issue. You're only getting this other issue on this frequently. This gives you a great idea of what's happening actually on your system. And it allows you to understand the code more closely and on real situations, not just on the ideal lab situation on a test. Like you're actually seeing this with some information generated from actually running code instead of like just hypotheticals. Now let's go back and revisit the other technique that I mentioned, tracer bullets. So again, it was these 3 steps. And now we're just going to do very small tweak on the second step. So we're still going to go and try find our target, know what it's the thing that we want to aim for. We're going to add a metric. We're going to create a new custom metric and keep track of it. And then we're going to see how far we landed from it. Like, is this matching what we expected or not? So here's the code that we had before. And we're going to do, again, very small tweak. We're just going to add this metric here, this count. We're going to say like, hey, based on the item name, count this, and also add this metadata. And this is the dashboard that we got from that. Again, we're blurring the data to protect the innocent. And we'll learn so much about what was going on under the hood. First of all, we learned that this code behaved a little bit like a funnel. We saw that, hey, lots of people are using item 1, some are using item 2, and so on and so forth. We learned the shape that we were not able to know beforehand. This was something that, of course, was not on our test suite, and this was not something obvious that you can infer from just looking at the code. We actually needed to see how the system was interacting in the context of the users. And talking about context, this gave us so much more data. This, first of all, gave us benchmarks, knowing like, hey, this is how often this is happening. And here on the right side of the graph, we can actually compare across multiple environments. We were able to compare like, hey, this is how happening on one geographic region versus the other one. This is how often it's happening on these different environments. And this is extremely powerful because, again, you can spot things that were not obvious. First of all, you can see the magnitude of how these things were doing. And then second, like you got a real picture of what's going on. And especially when you tie it up with time, you can see some patterns saying like, hey, looks like we're more popular in the afternoon than in the mornings. How come is that? And we learned so much about our code just by looking at these graphs. And it was simple. Again, we just added 1 line of code and we got this richness of information. And finally, there's so much more you can you get out of for free from using a tool like Datadog. There's this tool called Watchdog that we love. And the great thing about this one is that it tells us about issues that were not on a radar. Things that we were not looking for, we saw when we got alerted when they started changing, when there was an anomaly. And then that allowed us to react much quicker to issues that we're seeing. This alerted us like, hey, turns out your database is running hot right now. What's going on? This tool allows us to be data aware of our system. As before, we're like basically running blind. We didn't know what could be breaking. And this tool allows us to really get a clear picture of what's going on, even for things that we were not explicitly looking for. And finally, yeah, we just needed to go and do this all over again. Again, this software is an iterative process. You need to go and revisit. You need to rinse and repeat. But this really changed the way we were attacking this problem. This made things change a lot. At the beginning, week 1, we launched quickly. At week 4, we're like, okay, we're out 20%, pat ourselves on the back. Week 10, we're still stuck. We were like still at 20%, and we need to go much faster. A couple weeks passed, and then week 14, that's when we had our observability. And then just in 2 weeks, we went live to 100% of users. We went so much faster. And the reason why was not just because we were able to do this aggressive refactorings, but because we got our mojo back, we got our confidence back. The goal here was never to get to 100% test coverage. Our goal was to get our confidence back. Our goal was to feel like we could change the system and feel happy with those changes. My friend Ryan Kennedy has this amazing talk called Fear-Driven Development, and he presents this idea about maximums. So when you're afraid of your system, it's very easy to get stuck on a local maximum. So the lower point on this graph. It's very easy to say like, hey, I got this far and this is as far as I can go. It's easy to say like, it looks really scary to make changes to the system. Let's just stay here where I'm comfortable. Even though you know there is something, there's a higher maximum out there. There's the real point that you want to be stuck. Fear is really easily becomes a blocker. It really puts your team in a place where they cannot move anymore. And the fears compound really easily. If you feel like, hey, I cannot make this change without breaking the database. Hey, I cannot make this change without making performance. It just gets worse and worse over time. It just can get to a grinding and halting point if you're not careful, if you're not aware of how this is happening, and if you don't do something to address this issue. And the fix is easy. I like this quote by Julie Evans. When you have better tools and you have better process, the fear goes away. The more you are able to understand your system, the more you can trust your process, the fear just goes away, and it's very natural. And this is the way you deal with this situation. I like this quote by Jess Humble that says, testing is for known knowns, monitoring is for known unknowns, observability is for known unknowns. And again, these are 3 different techniques that it's important that you're aware of, and it's important that you use them at the right point. Testing is great. Again, tested pyramids will help you a lot, but the problem with them is that you need to know what can break on your system. You need to understand your system, and that way you can make these assertions. And it will get you far, but just for things that you know, that you understand completely. Then there's the idea of monitoring, and monitoring allows you to understand like, hey, this thing that I know, what are the cases? What are the edge cases? How can it break in ways that I was not aware of? That's just monitoring. Adding logs, you will get a great idea of like, hey, here is the ways this function, this method, this piece of code is acting in ways that I didn't expect. And there's finally observability. When you have enough metrics, when you have enough ways to see your system, you will start seeing things that you didn't know about. The system itself will start telling you like, hey, you're not aware of this, but this is what's actually happening. Like, hey, you had a memory leak and you didn't know about it. But now that we're tracking that number, on the machine, you can look into that. You can adjust your view to address a point. Observability is about knowing about what you don't know. It's great. And again, you don't need to fear the unknown. There are things that you won't know, and that's no reason to be afraid. You just need to find your lighthouse. You just need to find the tool that can help you feel more confident and more in tune with your system. So yeah, I invite everyone here to pick a destination, know where you're going, find your lighthouse, and then look at the shore. You just need to find the right tool that provides you that light into your product. Thank you for listening. I'll leave you here with a couple references. Observability is a huge topic, and it has many things that I, of course, could not cover on this presentation. So I invite you to check out all these books and talks by great people. And then finally, just a reminder, we're hiring. Check out about.nextdoor.com/careers. Thank you.